Note I often jump between decimal and hex. My brain works that way. Sorry for any confusion. In my current project, the banana horde appeared like this. This happened because I moved the BG11 screen to the left. The banana horde is on BG2. BG2 generally has things you don't interact with. BG2 in most cases is used as the far background. You can isolate BG2 in most emulators. BG2 moves at half the speed as BG1 in DKC. This is to create a parallax effect. BG2 can be one or two screens, but this part is not important for this problem. Banana horde is one screen. Most important. BG2 repeats on the SNES. Consider this. Conclusion. We only moved BG11 screen to the left. Therefore, BG2 only moved 0.5 screens left. Tilemaps point to chars in VRAM. Chars are 0 by 20 bytes representing an 8 by 8 of pixels. Up to 32 chars can be displayed in a row and 28 per column. 32 times 8 equals 256, or width of the screen. 28 times 8 equals 224, or the height. In ROM, each tilemap index is composed of 2 bytes. Each index specifies char number, palette, priority, X and Y flip. My thought was, if normal gets shifted, why not provide a shifted tilemap? Note this only works because this image isn't used elsewhere. So my goal became to shift the tilemap half a screen. So how do you go from this to this? To help visualize, here is a simplified example. Think of a tilemap as a picture frame where you start in the top left and go through each index in each row in order. So the banana horde tilemap looks similar to this in ROM. I want to shift the tilemap left by half a screen, or like how the image on the right shows. Notice how each row still contains exactly the same data, just in a different order. So I wrote this function to achieve this. Let's break it down. First, I define a function with two parameters. Tilemap offset just gives the location of the tilemap. Tilemap size tells me how large the data is. On this line I use one of my other custom functions. This function returns an array of integers where each integer represents 2 bytes of data. On this line I just create a container for my new tilemap. Since tilemap size is variable, I calculate a y limit. I divide by 2 because I want the limit to represent ints, not bytes. I divide by 0 by 20 because there are 0 by 20 indices before a new row. Here I start my first loop, looping through the rows of the image. For every new row, I start at the middle index of the row. X is 0 by 20, 32, indices wide, so 16 is the midpoint. I start a do, while loop to go through the row. I use do, well because it becomes easier to manage my X index like this. I now get the value at this index in my array. Y asterisk 32 represents current row. X represents index in that row. I then add this value to my new tilemap. I increment my X index. I could do this elsewhere, but readability is far more important. If our X index hits the end of the row, restart the row. If our X value is not in the middle, loop again. Else go to the next row. Finally, we write our new array to ROM at the offset initially passed to us. Here is the result. Thank you all so much for watching. Feel free to leave any questions regarding this in the comments section.